Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I actually want to start off our discussion on projections with something far more fundamental. And that's actually the way that we are able to measure locations on the surface of the Earth. Or put another way, right, the three-dimensional location on a sphere. Now, we're going to say on a sphere for now because it's actually a little more complicated than that. And we're going to get into some of those complications in the next video. But for now, I want to focus on this sort of idealized concept of a true sphere. Now, to sort of jump ahead a bit, what we're going to be talking about is this idea of what are called spherical coordinates. Or to use a term that we see more frequently in cartography and GIS, we're going to be talking about latitude and longitude. Now, if you're anything like me when you were starting off with GIS and cartography, you had seen these terms thrown around a lot, and you might have maybe briefly considered what they meant, but you probably didn't give them too much attention because you were so focused on a lot of the other technical aspects and just learning software. So what I want to do is I want to sort of review these concepts in a very fundamental way so that you have a really solid understanding of how we get the location before we move on to projecting it onto a map. And so what I want to do is I want to start off with a thought experiment. So you can imagine this graphic that I have here as being a ping pong ball with a Sharpie dot on it. And if you want to replicate this, you certainly can. But what I want you to do is I want you to take just a minute and think conceptually how you would go about representing the location of this black dot given just the information that we have this pure white sphere and a black dot. How would you go about explaining that location to someone? Okay. So hopefully you paused the video and thought about it, and you probably come to the conclusion that using just that information, it's actually an impossible task, right? There's nothing you could do to tell somebody the location of this black dot without any other information. And in specific, what we need to do here to be able to explain the location of this black dot with any degree of certainty is to actually set up, spoiler alert, a coordinate system. But in order to do that, just like in 2D mathematics with a Cartesian coordinate plane, we actually have to set up a couple of axes so that we have reference points for dealing with the location. And so those axes that we set up are called meridians and parallels. And what I want to do is I want to talk about the prime meridian and the equator. So if we look at the sphere, what we need to do is, the goal is to divide it into 4 quadrants, right? North and south, and east and west. So for north-south, right, that's a pretty easy question to answer, right? Where do we put the line that divides the north from the south? Well, that's pretty easy, right? We just pick a line that cuts the sphere at its widest point, right? So hopefully I can do this without butchering the sphere too badly. Right, you can imagine that that's pretty straightforward, right? Pick the point that divides the sphere at its widest point, and this is going to be the equator. The equator, right? That's going to be our north-south division. North, south. But let's take a minute and think about east-west for a second, because east-west is a little bit trickier. Because when we were going north-south, right, we could just pick the point that was the line that divided it at the widest spot and be done with it. But if we were to go north-south, right, any circle that we make going north-south is going to be the same width, right? The sphere doesn't have an east-west division that's going to make it any bigger than any other east-west division. And this caused a lot of problems back in the history of the beginnings of cartography, right? Because anybody could say, well, the east-west that runs through my house is the division line. And somebody else could say, no, it's going to be the one that runs through my house, right? And so we actually had to come to a universal agreement. And that universal agreement was to create what's called the prime meridian. And the prime meridian was chosen to run through Greenwich, England. So again, that's just a convention, right? That's something everyone's agreed on. There's no sort of definitive reason why that was chosen, right? With the equator, it makes sense. It's the widest point in the Earth going north-south. But for east-west, we had to make an arbitrary decision, and we chose the one that goes through Greenwich, England. Right, so to divide north-south, right, we have the prime meridian. Right, the prime meridian. Okay, so now we have our axes. We have equator, we have the prime meridian. So how do we go about getting more granular than that? Well, to do that, we have to talk about angles. Right, if you've ever dealt with latitude and longitude, then you're going to already know here that latitude and longitude are measured in angles. And so what I want to do to explain that is I actually want to imagine that we cut the Earth through the equator to create a circle. Right. So this circle here is the Earth cut through at the equator. And so you can imagine that running through the equator would be the prime meridian. Right, so this is the prime meridian. Right, in this case, it's measured as a straight. I'm visualizing it as a straight line. And right here, we have the center of the Earth. So let's go ahead and put our point. I'm going to make it green here so that it's visible. Maybe say right there. So this is our point of interest. Okay, right. So how do we measure the location of this point given our prime meridian the center of the Earth and our point of interest? Well, the way that we do that, we actually need one other point here, and that is actually the point where the prime meridian intersects the circle here. All we have to do is measure at the angle. Let's do this in orange. We just have to measure the angle that's created between the prime meridian, the center of the Earth, and the point of interest. Right? This angle right here, this is our longitude. You'll often see longitude abbreviated as lambda. Right? That's all it is it's the measure from the prime meridian to the center of the Earth to the point of interest. And you can imagine we can do something similar here for longitude, right? If instead of cutting it at the equator, we cut it at the prime meridian. Move this up just a little bit, right? So in this case, this is a top view. Right, we cut it in half, we're looking down. In this case, this would be a side view. Right, we cut it along the prime meridian and we're looking in. And so you can imagine in this case, right, the equator is cutting the circle in half kind of like that. Right, and we could put our point, say, maybe here. This is our point of interest. If I can make that a little cleaner. This is our point of interest. Right, so again, we have the center of the Earth here, and we have the point where the equator touches the surface of the Earth. Okay. So to get the latitude, right, all we have to know is the measure of the angle created by the point of interest, the center of the Earth, and the place where the equator intersects the surface of the Earth. All right, this angle right here, this angle is going to be our latitude. And you'll oftentimes see latitude abbreviated with a phi, which looks like a 0 with a vertical line through it. So let's just sort of take a second here and let's recap what we've learned. So we now know that in order to determine a location of any point on a sphere, we need to have a reference system that uses a north-south axis and an east-west axis. And we call those axes the equator and the prime meridian respectively. And that we can measure any point on the sphere based on two angles. One being the angle between the prime meridian and the point, we call that longitude, and that's east or west. And the angle between the point and the equator, north or south. So let's go ahead and just wrap this up by defining the terms here. So we know that latitude is the angle north-south of the equator and we know that longitude is the angle east-west of the prime meridian. Okay. The last point that I want to make here is in terms of how we sort of explain these measurements. Okay. So, in terms of latitude, right, it's north or south of the equator. So you could imagine here that as we go, as this angle increases, actually let me give us a little more space here. And I want to draw a new circle here. Okay. So again, we have our equator cutting the circle in half here, and we have the point, right? As this angle increases, right, the maximum angle you can have is 90 degrees, right? This right here, right, that would be 90 degrees north, right? If we go back, now let's say we're over here, right? If we're over here, and this is where things might get a little bit confusing, right? You don't measure it like that. It's not 91 degrees. Instead, it would be measured from this side, and it would be 89, 87, somewhere in there, degrees north. Same thing south, right? If you were to go south, right, if we were to have our point down here, right, this would be 90 degrees south. So latitude is north-south, and it goes from 90 degrees south to 90 degrees north. Let's talk about longitude. Right? Okay. So we have our circle, and we break it in half with the prime meridian. Right? So you might think that it would work the same way, but it actually doesn't. The prime meridian, right, if you were to go from here to here, if your point were here, right, this angle here right, that's 90 degrees, and in this case, right, we're east, so it would be 90 degrees east. Right, but if you were to go here, right, you still measure from the same point. This would actually be something like 110 maybe? I don't know. 110 degrees east. So the key difference here is that longitude actually is 180 degrees west to 180 degrees east. Right? This is a distinction that a lot of people mess up. Latitude goes 90 to 90, longitude goes 180 to 180. Hopefully that makes sense. Hopefully this was mostly a review for you. Hopefully you have a good solid understanding now of where latitude and longitude come from, what they're actually measuring, and the references that we're using and why we're using them. And as always, if you have any questions, please reach out. Thank you.